In the first two videos, George, KJ6VU, and I took a deeper dive into the station controller components and the software behind the hardware. If you haven't seen them yet, I'll leave a link in the description. Today, George is back to take an in-depth look into the various controller modules along with what's coming soon.
Hey, it's Michael with EX Engineering, and I'm back with George from KJ6VU from Sierra Radio Systems. And George, I'm really excited to have you back.
Thanks, Mike. Thanks for having me back.
So today we're going to kind of dive into the various station controller hardware modules. So why don't you just kind of give us a rundown on the various pieces?
Sure. There's 5 modules and a bunch of accessories. The first core module is a PC. We use a Raspberry Pi, but you can use any PC you like, but the ones we sell is a Raspberry Pi pre-configured. And then there's various input and output and control modules. So I think the best thing to do is just show it to you. So let's go ahead and switch my camera here to a picture of a typical station controller. Now, the way the station controller hardware is architected, there's a kind of a mix and match of different modules, and you don't need to use all of them, or you could use 3 of each. So you can build up your station as you like. So this is a typical station controller that you see here. What you have is 4 modules plus a hub. The lower left module, this one down here, is our Raspberry Pi host adapter. And so you can see there's a 12-volt Anderson power pole or barrel connector inputs. We provide our own 12-volt power supply to run the Pi, so you don't need to use an AC power supply, so the whole station controller can run off of 12 volts. So we provide the SD card with the built-in flows for Node-RED with the control to control and monitor all of our modules. The Ethernet plugs into the Raspberry Pi, as you would expect, and then you'll see that there's 3 RJ45 connectors that are Ethernet style connectors, but they're not Ethernet. These are the Ethernet cables that are running RS-45 data and 12-volt power like PoE. If I just had one module, I could just take one of my connectors here and connect it directly to that module, and it provides power and data between the two. So I only need to inject power into one module. If you have up to 3 modules, you can use these 3 connectors that are built into the Pi. If you have more modules, then you could use a hub. So the hub here allows you to add 5 modules, and also gives you, in addition to the modular connectors, gives you twisted pair RS-45 on the hub as well as on every module. So there's 3 modules that we're showing here. The first module in the upper right-hand corner is what we call our general purpose I/O or GPIO module. The GPIO module has about 18 input and output channels. So there's a bunch of terminal blocks on the top and bottom. What you see from left to right here is 4 analog voltmeter inputs that are ground referenced up to 50 volts each. Then there is 4 open collector outputs, so you can switch large 12-volt relays or an external pull to ground. Like, for example, on a flex radio, if you want to, let's say, pull the remote pin on the radio to turn the radio off, you could use one of these open collector outputs for that. The next bank is 4 single pole, single throw, 2 amp small signal relays. So you get dry contact switch closures for 4 channels. And then there's 4 digital inputs. These are active pull to ground, and these are used to indicate switch closures. This could be a cabinet switch indicate. It could be a door alarm. It could be maybe a pressure sensor on a propane tank that indicates when you're below a certain level of fuel. They're all opto-isolated inputs for the digital inputs. In fact, everything has protection on it. Even the analog voltmeter inputs is clamped, so you can't go over voltage and damage the electronics. Up at the top here, you have 2 jacks for digital temperature sensors, and they just plug in, and those temperature sensors are a little metal cylinder that has the sensor in it. There's no calibration required. All of the modules have a RS-45 modular connector as well as a pair of RS-45 screw terminals if you want to use twisted pair versus using Cat5 cable. And of course, all the modules have their own built-in power supply and their own processor. And there's also dip switches for configuring the address and other operating parameters. The next module over to the right here is our HF and 6 meter coax relay. It's a 4 position. This is the common input. So you have position 1, 2, common, 3, and 4. These are latching relays, so if you lose power, it'll stay in the last position that you're in. By the way, on the modules also have LCD displays. So on the GPIO module, it rotates through all the state of all the inputs, and on the coax relay, and it's kind of too bright to see it there, but it'll tell you what port it's on, and you can have a label that tells you what that particular antenna is. Then the third module we have down here is our watt meter module. This is a controller for a watt meter. You would have to have an external directional coupler, and the directional couplers that we are using are made by a company called Wavenode. Wavenode makes meters and couplers, and we don't need to use the meter, we just use their coupler. And the little connectors here are 6-pin DIN connectors, mini DINs, and that's the kind of connector they supply. So you can buy a HF or VHF UHF or 1.2 gig coupler from Wavenode, and you plug them in, and we have calibration tables pre-built for those particular couplers. And you can mix and match. You can have 2HF, HF VHF, VHF 1.2, HF 1.2, whatever combination you like. By the way, you can see here the LED just fired. What's happening is the Raspberry Pi is running the Node-RED flow, and every 30 seconds or so, it's polling each of the modules to get the latest state. Now, every time this is polling the watt meter, you'll see the LEDs turn on. Also, if you actuate anything, like if I switch a coax relay or flip a relay on the GPIO module, or if I tell the watt meter module, you can force it to give you a measurement right away. And you would also see the wattage here. This one is not hooked up to a coupler, so it's still showing you the boot IP address. I talk a lot about how the system is so easy to use out of the box. When you get the system, each module is in its own separate anti-static bag. You take each of the modules, you plug in the Cat5 cables between them, and then you plug in Ethernet to your network, and you plug in power. A minute after the Raspberry Pi boots, all of the displays will show you what the IP address is of the dashboard. So you point your browser to that IP address, and then you'll get the dashboard, and you just start using the system. It's that simple. So that's an example of the typical station. And Mike, we have a brand new module that we're coming out with right now, and that's this one over here. We'll see if we can pull some focus. Or not. So what you're seeing here is our latest antenna control module. So this guy is a custom built for controlling DX engineering antenna relays. So in working with the engineering team at DX Engineering, we were looking at HF high power coax relays like kilowatt relays, and vertical phased array control modules, and Yagi stack control modules, and so on. And we thought, we can make one controller that can control any of those devices. So this particular one has 10 different personalities built into it. And with the dip switches down here, they say configuration. If you have, let's say, for example, a array stack, and you want to be able to switch the phasing between the arrays, you set the dip switch for that particular model, and on the dashboard it would say, let's say, a particular position or a direction on the antenna system, and it would set the pattern of relays to control that particular configuration. Some of these devices require ground switching, some of them require 12-volt switching. All of the external controls can be jumper selected, 12 volts or ground. So we can control a wide variety of different kinds of antenna relays with this module. So that'll be the latest one, and hopefully that'll be available in the DX Engineering store in the next month or two. So that's kind of a quick overview of the modules.
Yeah, this is the one I'm most excited about for me. So that's a little self-serving, but
I think this is going to be really hot. I'll tell you why. Like one of the things I had a customer call and say, your 4-port relay looks great, but what I really want is I need to switch a kilowatt. And so we thought about that, like, well, we could build a kilowatt relay, but you guys already have one. So what's the point of us building that relay? You already have a really good kilowatt 8-port or dual 2x8 relay. Wouldn't it make more sense for us to just build a controller for that relay? And that way we can retrofit existing relays with our system and automate it and control it remotely.
Absolutely. Now, it makes all the sense it does. And I have a legal limit plus amplifier. And so that's that I need that.
Yes, you do.
I never drive it. No, that tube's $1,200. I'll never drive it hard.
Yeah.
But I go back for a second because you were talking about the other antenna relay.
Mm-hmm.
Can you tell us what the port-to-port isolation is on that?
Yeah, the port-to-port isolation is about, as I recall, I want to say 55 dB to 65. It varies between 80 meters and 10 meters. There is some variation when we swept it, but it's up in the 50s, high 50s.
Okay.
So it's I would say it's a good 100 watt standard kind of station coax relay. It's fine for HF. It's fine for 6 meters. Actually, I have a customer who's running 300 watts through it, and so far they haven't burned it up. So it'll handle more than 100 watts, but we're only rating it for 100 watts. And if you need something bigger and better than that, then you can go to the DXE controller module I just showed you, and then pick your third-party relay from there. We also have a VHF UHF relay module, which looks totally different. It comes in an enclosure. And the way we are able to operate that at high frequency is that it has an RF impedance controlled 2-position relay, a Tohatsu relay built into it. So you get very low insertion loss and good isolation with that for 2 meters and above.
Okay, very good. Yeah, and I could use something like that on the shack end just because I usually have more than one HF rig going at the same time.
So by the way, important to note that a lot of people think about that as one radio, 4 antennas. In my shack, I have 2 of them. I have 4 radios to 1 antenna, and then 1 antenna to 4 radios, and I connect them together. So the commons are connected. So this way I can go any one of 4 radios to any one of, in my case, 3 antennas in a dummy load, and any combination that I want, and it works just fine.
Yeah, and as you can tell behind me, I'm not lacking for
Yeah.
radios right now. Okay, so what do I need to get all this going? I have this pile of boards. What do I need to make them all work?
So what you really need, we make it really simple. So you decide, first of all, what do you want to be able to control and monitor? So if for the typical station, we built a set of modules where we would expect the average user to want basically one of each of the modules, because that kind of covers your bases. Now, some people look at that and say, well, I don't really need an external watt meter because my radio has a watt meter built into it. And while it would be nice to have an external watt meter, I don't need that. So, okay, you don't necessarily need that. In some cases, people really want that. Sometimes you have more things than one module can handle. Like I have a good friend of mine up in Canada who's got like 3 of this and 4 of that. I mean, he's got like a dozen modules because he has a crazy complex remote station. Now, most of us are not in that league. So really, I would say the standard thing you would want is the Raspberry Pi, because you need that as your host, and a GPIO module at the bare minimum. And this gives you basically DC voltmeters, temperature sensors, relay switching, etc. And the next thing would be an antenna switch, and that could be ours, or it could be our controller with a DXE, higher power relay. I'd say that's the most common starting point. And if you buy those, let's say those 3 modules, plus the installation kit, which includes the mounting hardware and the little interconnecting Cat5 cables, then you have everything you need except 12 volts. So, and there's a power pole on the Raspberry Pi. So if you can provide 12 volts to the power pole, you've got everything. And to set it up, it takes more time to screw it to a board or mount it in a chassis than it takes to actually plug it together, turn it on, and start using it. So the user experience was really what drove the architecture and the way the software and the way the firmware works. So you literally, if you're just setting it up on your bench, you literally take each of the 3 modules, plug in the 3 little Ethernet cables, apply power, and it just comes up and runs. There's no coding, there's no customizing, there's no configuring, there's nothing to do. It's that simple.
That's really awesome. Okay, so, and I know you've touched on this already, but how difficult is this to set up and get it going?
Well, as far as setting it up and getting going, I just described kind of what it takes to do that, except for hooking it up to other stuff. So the biggest amount of time and effort you're going to spend is to physically mount it somewhere in a box, in a rack, on a wall. You got to put it somewhere. So that'll take a few minutes to figure that out. By the way, for mounting, you can mount it several different ways. The modules that we supply um, have a circuit board that you can see, but what you really can't quite tell is there actually are two of them. There's the electronic circuit board itself, and that sits on a carrier, and that carrier plate is non-conductive. And so that means you're not going to short anything out, which is a big plus. Now you have to mount it to something. There's mounting holes on the carrier base plate, so you could mount it in a chassis on standoffs or just with screws. What I personally prefer is to mount it with DIN rails on a wall or on a piece of plywood in a cabinet. And this is kind of harkening back to the old telco wall punch block kind of days where you had a piece of plywood and you can mount anything you want to that piece of plywood. This works perfect for that kind of a case. And so what I was showing here in the lab is exactly that. It's a piece of plywood and it's got DIN rails. DIN rails are about 1.25 inches tall. They're kind of U-shaped extruded aluminum. You just screw it to the plywood, and then there's plastic clips that screw into these little holes on the side, and then the module just snaps on the DIN rail. And that's all there is. And the nice thing is you can pop them off, you can pop them on, you can move them around to your heart's content. The biggest setup is going to be how you wire the interface to whatever it is that you're operating. So if you take, for example, the coax relay, the coax relay board has coax connectors, and you're just running cables from your radios to the BNC connectors or your antenna cable to the BNCs. And you hook up the cable and you're done. In fact, we make 6-foot BNC to PL259 cables that are in the store at DX Engineering. You can buy the cables. You don't even have to make a cable, and you literally plug in the cables and it just starts running. With, as I described, setting it up. If you're going to hook up the GPIO module where you've got 18 different I/O lines, there's more to hook up, right? So you might say, for example, I'm going to use the voltmeter to measure my power supply voltage. Okay, well now you need to run a little piece of zip cord from those two terminals to your battery terminal. So you're going to make a terminal and you're going to run the wire. Or if you want to, let's say, turn the AC on and off, the AC power to your station, you're going to need some kind of DC controllable relay box, which you can buy off of Amazon. It just takes, a little opto-isolated 5 to 12 volt loop, and you can take the GPIO module that has relays like this, and we could put 12 volts on one of those pins, and there you go. You just hook that up to your external relay, and you can turn AC power on and off. For let's say some radios have soft controls, like for example, a Flex radio has an RCA jack called remote. And when you, I forget if it's you ground it to turn it on or ground it to turn it off, but it's either grounded or floating to turn the radio on and off remotely. And you can just take one of the GPIO module open collector pins, wire it to that remote jack, and now you can remotely turn the radio on and off. Another thing with the Flex, by the way, is if you want to measure RF power, of course, you can look at the power on the Smart SDR software. But if you want to look at a real watt meter external to that, what I do is I hook one of the GPIO pins to the CW key input. So when I want to really measure my output power, I'll put the radio in CW mode. I'll press the button on the dashboard to key down the transmitter. Then I'll look at the watt meter module and see what the power is. So that sort of thing is really easy to do. So it takes a little thought about what you want to actually hook up to this. Hooking up the watt meter is super simple because the directional coupler has 2 antenna connectors. So you go from your transceiver into the coupler, then from the coupler your feed line to the antenna, and that's it. Plug in the little DIN connector that's already pre-configured, and then you have to tell the module what band that sensor is on. Is it HF or VHF or 1.2 gigs? And once you tell it which module, it knows how to read the module, and you're off to the races. And that's about it, Mike.
Yeah, so this is really expandable. It's not a big deal to add extra stuff over time then, right?
Yeah, super easy. So if you look at any of these modules, there's dip switches on the modules, and 4 of the positions on the dip switch set the address of the device. So normally your main control computer, your Raspberry Pi, is address 0, and with 4 bits, it means you can have 15 different modules just by setting the dip switches. You can actually set addresses up to 99 in software through the UART. So every module has a USB-C port, a console port. And in normal use, you don't use that console port. You use this for flashing it with new firmware, or if you want to set some software parameters, you can go in and through the serial port with a dumb terminal and just configure it. So so the addressing is real simple. So if I wanted, let's say I said, okay, I want 2 of these antenna modules. This one is set for address 2. I get another module. I set it for address 3. I copy my Node-RED flow. I change one number in the flow, and now I got 2 modules running. So it's very expandable and very easy to do.
So I'm the customer. If I decide I'm going to either jump in and buy this or I want to learn more about it, where can I find more information about it?
So that's a great question. So we have a groups.io group called Station Controller. It's a private group because it's really limited to, it's open to any ham who wants to join. So there's no limit, but we want to make sure that everybody that's there is supposed to be there. And so you apply to join. It's called Station Controllers. You can find it by just searching groups.io. And once you join, then you'll be in the forum with everybody else who's using the system. You can see what their experience is, ask questions, and so on. All of our documentation is there, including not only the basic installation guides, but all of the reference manuals for all the modules, all the commands. Not that you need to know them, but if you want to write your own code, all the commands are there. The theory of operation manuals, all there, all the advanced manuals, so everything is there. And there's pointers to contributed examples of stuff, as well as downloads of Node-RED to get the latest version of the flows from us. So that's certainly a good resource. I've been on a couple other like YouTube channels talking to folks about this. So YouTube's a good source. Just search for Sierra Radio Station Controller. You'll find stuff. And let's see, we're going to be at Hamvention in a big way this year. So we'll have all this on display and being demonstrated there. So that'll be a lot of fun.
Yeah, I'm really hoping you're going to join us in the DX booth.
I hope so.
So what kind of support after the sale?
Yeah, so good question. So the best thing to do is join the groups.io and post questions there. And usually I get around to answering the questions as fast as I can, but half the time other people jump in before I get there and answer the question for you. So it's a very friendly group. So that's the best place to go. Now you can also email me directly. That's fine as well. So we can have a private conversation about it, and I'm happy to help you with that. So any support questions, come into the community, shoot me an email, and then we'll be happy to talk to you.
And I'm really curious, what else do you have in the pipeline?
Oh man, well, actually, we have a really big adjacent product, which is a software offering coming, and we're just going into beta as we speak, and we'll be in full production by Hamvention. And it's a software product called Eyesshare Radio, and it's not a piece of software you run yourself. It's a cloud-based service. And what it allows you to do is to manage your remote station for multiple users. And I'll sort of give you the scenario is if I have my own remote station, my problem is I have to be able to remote the radio, problem solved by manufacturer. I have to be able to turn things on and off and monitor things, problem solved with station controller, and I'm kind of done. Now, what happens if you said, okay, that's all fine and dandy, but I want to set up a remote station for my club, or I want to set up a remote station for myself and my 3 buddies. So you start to run into some problems right away. The problems are things like scheduling, access, who can get access to it. So the first thing we started doing is we looked at all the different vendors making radios for remote operating. And you can remote anything, but some things are easier to remote than others. So if you kind of go down the list, probably the easiest brand to remote is Flex Radio because they've been doing it forever and they understand that. So they're really kind of number one. I would say Elecraft's probably going to be a pretty close number two. ICOM is probably number three, and then everybody else. Now, and the reason I say everybody else is like not everybody else is providing their own software and stuff to do remoting, except those manufacturers. So take Flex. With Flex, when you want to remote any of their radios, you log in to a system called SmartLink. So you have a user ID and password, and you log in, and it authenticates you and allows remote access to your radio, and that's all fine. And if it's only my radio and I'm the only user, life is good. But if, let's say, I want to let I want Mike to use my radio, I have to give you my login credentials. Well, I trust you, so that's not a big deal. But if I have a club, like here, I live in Portland, and here we have one of our clubs, the Portland Amateur Radio Club, has 160 members, and we have a remote station that happens to be a Flex 6400. They have to hand out the login ID to everybody. and so maybe you don't want everybody to have access to it. Or what happens if, let's say this weekend we're taking an antenna down and I don't want you to have access to that antenna? What am I going to do? I'm going to send everybody an email and say, hey, guess what? This weekend the antenna's down. Don't use it. Use the vertical, not the beam. Who's going to read the email? I mean, nobody's going to read it, right? So you can see as you start to get into multi-user remote operating, you have 3 or 4 big problems. Number one is you really would like to have individual login IDs for each user. Number two, you want to have some way to supervise what the radio is doing to make sure it's being operated either in accordance with the legal regulations of your country or whatever rules the owner of the radio wants to let you do. And then number three is I want to schedule time. And how do I schedule time? I could use a Google Calendar, but that's kind of cumbersome. I mean, it'd be great if there's a better way to schedule things. So we decided to build a software product, and we call it Eyesshare Radio. And Eyesshare Radio does everything I described, and it runs in the cloud, essentially located so you don't have to install that. You install a little client on your PC, and that little client basically makes the connection to our cloud service. And what you can do with it is, as a club, you can say, all right, we're going to create an account for whoever wants to sign up for our remote radio. When you create an account, let's say Mike, you're in my club and you're gonna sign up. That's great. You get your own login ID. You don't ever need to see SmartLink ever. you get your own login, and you'll tell me, like, what class of an operator are you? Oh, you're an extra class operator. Okay, so we're going to allow you to transmit in the extra band. On top of that, I might look at that and say, I don't at the club station, I don't have a 60-meter antenna, so I'm going to prevent you from transmitting on 60 meters. I might also say I've got a 100-watt radio, and I'm going to let you run 100 watts sideband and 100 watts CW, but I'm going to limit you to 50 watts digital. So I can set up all of these constraints so that you can only operate in a way that I, as the owner of the station, want you to operate for either your own legal safety or our station's health, right? I want to constrain that. And then there's a place you can sign up and book time. We as a club can block time and say, hey, look, next Saturday is the big contest, so we're blocking the time. Nobody can use the station. Otherwise, it's first come, first serve. So all those features are there, and we also monitor the radio. So like if you go into, say, Smart SDR and you say, well, I'm going 100 watts and run FT8, and if the system admin said, no, you're only allowed 50 watts, we're monitoring the radio in software. And as soon as you set it to 100, we're going to kick it back to 50. So we're going to prevent you from doing or transmitting out of band, or transmitting out of your license class band. So, we'll do all those guardrails for you. So, and also one last thing is it's also integrated with the station controller. So there's even inside Eyesshare Radio, there's not Node Red, there's another control panel for the station controller that'll come up if you have one. And so you can do all the same station controller stuff, but it's not running Node Red. And the reason for that is that when we ship the station controller with Node Red, you get the source, and anybody that has access to your computer could modify that Node Red program. So when you go to share this to a big group, you don't want them getting in there and messing around with your Node Red code. So we have a dashboard that's been replicated inside Eyesshare Radio that prevents you from being able to do that. So That way, this is all in service of making it easier to manage a club station.
I think that sounds amazing. I'm sure.
Yeah, and by the way, it's not going to be limited to Flex. So right out of the chute, we went to Flex because that's really where a lot of people are doing remote stations with Flex. And so we started working with them, and they're like, this is great, let's work together. And they've been wonderful. There's no chance we could have done this development without their help. So their engineering team has provided us a lot of internal information to enable us to do this, because you can't just do this. You have to really get to the guts of a lot of the Flex hardware and software. So they've been wonderful. Having said that, there's nothing that prevents you from using certainly the station controller, and even Eyesshare Radio will work with other radios someday. Now, station controller today works with anything. Eyesshare Radio only Flex, probably until the end of the year, and then we'll see where it goes from there. I got to say, though, working with Flex has been really good because they understand the problem. They've built a lot of features into their equipment to make all this possible. And when I look at other, let's say, well, could we do this with a Yaesu radio? Well, a lot of the features you could do with a Yaesu radio, but they don't even have the notion of signing into the radio to begin with. So, there's some infrastructure that has to be built out for radios to work that are not really built to be remoted off the shelf with any kind of multi-user security and authentication.
Yeah, so that'll probably be a lot of work to figure that out. But
yeah, and frankly, we're going to see what the demand is. My gut feeling is that, like, the people who are really interested in this, a lot of them are already using Flex radios or thinking about it, and so that's just a really good fit. And beyond that, we'll kind of see where it goes. But that's where we started, and we're quite happy with that.
Yeah, and honestly, I've spent a lot of time working with Flex in the past few weeks, and they've absolutely been amazing. So I'm really excited to see where all this is going to land. But George, I really appreciate your time today. I'm really excited to move into the fourth video, and thanks so much for your time today.
Yeah, my pleasure, Mike. Thank you so much for having me. I appreciate it.
And again, check out sierraradio.net and, of course, the DX Engineering website. 73.
And that wraps up the third video in this series. In the next video, we'll discuss building a remote station, the right combination of hardware and software, and setting it up for multiple users. You can find more information on the DX Engineering and Sierra Radio websites, and I'll leave a link in the description. Hey, thanks for watching today. I'm Michael, K-I-A-R. We'll catch you on the next one.